Good morning. This week in review, we will conclude our unit on transformations. Monday and Tuesday, dilations. Wednesday, similar figures. Thursday, perimeters and area of similar figures. And Friday, we will wrap up with mixed review. Next week, Monday and Tuesday, we have no school for teacher in-service and election day. Wednesday and Thursday will be part 1 and part 2 of our unit test. And we will wrap up the week with an introduction to angles and triangles on Friday. Dilations day 2. So there are 2 types of dilations. We refer to them as either a shrink or a reduction. When we're looking at a shrink or a reduction, it's the type of dilation that occurs when the scale factor is less than 1 but greater than 0. Where the scale factor is less than 1 but greater than 0. When we're looking at scale factor, remember pre-image to image. Pre-image to image. A shrink or reduction will result in the image being smaller than the pre-image. For the other type of dilation, we talk about a stretch or an enlargement. This is the type of dilation that occurs when the scale factor is greater than 1. Where the scale factor is greater than 1. Again, as you look at the pre-image allows the image or results in the image being larger, and it results in it being larger than the pre-image. So a reduction, it gets smaller. Enlargement, it gets bigger. A shrink gets smaller. A stretch gets bigger. But make sure that you understand that both allow the figures to remain the same shape. The same shape. All dilations have the same shape, but different sides. Different size. Same shape, different size. This is results in a similar figure. A similar figure. Remember that rotations, reflections, and translations have congruent figures. Dilations lead to similar figures. Dilations lead to similar figures. So the vertices of a triangle, A, 1, 3, B, 2, 3, C, 2, 1. It says draw the image after a dilation of a scale factor of 3. Well, before we draw scale factor of 3, we said that a shrink, the scale factor is greater than 0, but less than 1. Greater than 0, but less than 1. The scale factor or K value is greater than 0, but less than 1. Greater than 0, but less than 1. A stretch So in our first example, the vertices of a triangle are A 1, 3, B 2, 3, C 2, 1. Draw the image after a dilation with a scale factor of 3. Scale factor of 3. Identify the type of dilation. So first we can identify the type of dilation because it gives us the scale factor. A reduction, reductions, the scale factor, and we'll use the letter K to represent scale factor, is between 0 and 1. So K has to be greater than 0, but K has to be less than 1. So for an enlargement, K, or the scale factor, and again, we'll use K to represent scale factor, simply has to be greater than 1. So is 3 between 0 and 1, or is 3 greater than 1? We know that 3 is greater than 1, so this figure should result in an enlargement. It should get bigger. When we enlarge a figure, all we do is multiply 3 times all of the coordinates. So A, B, C, 1, 3, 2, 3, 2, 1. I multiply each of them by 3. So A prime, 1 times 3 is 3. 3 times 3 is 9. 2 times 3 is 6. 3 times 3 is 9. 2 times 3 is 6. 3 times 1, or 1 times 3, is 3. So this problem is already worked out for us. Let's see if that worked. So it says multiply each x and y coordinate by the scale factor 3. A is 1, 3. To get A prime, we multiply 3 times x and y. We end up with 3, 9. B is 2, 3. We multiply to get B prime, each of the values by 3. We end up with 6, 9. And for C, 2, 1, we multiply the x and the y values by 3, and we end up with 6, 3. So when we plot those coordinates, A, B, and C, again, remember, we go right 1, up 3. For C, we go right 2, right 2, up 1 for C, and for B, right 2, up 3. Connect the values. A prime, 3, 9. B prime, 6, 9. C prime, 6, 3. So some of you may think that because the values move, that this is a translation. However, remember that translations are rigid transformations, which means that they maintain the same size and shape. From A to A prime, B to B prime, C to C prime, what we get is not a similar not a congruent figure, but a similar figure. It is similar. So this dilation is an enlargement or a stretch because the scale factor is greater than 1. Scale factor is greater than 1. And so if we were to draw a line through the origin, for all of the points, you would notice that all of them fit the pattern for a dilation. So it says the vertices of a rectangle are W, -4, -6, X, -4, 8, Y, 4, 8, and Z, 4, -6. Draw the image after a dilation with a scale factor of 0.5. A scale factor of 0.5, identify the type of dilation. Again, when we look at a reduction versus an enlargement, is K or scale factor greater than 1? Is 0.5 greater than 1? If it is not, we should the result should be a reduction, which means the image should get smaller from the pre-image to the image. So again, we're going to multiply each X and Y coordinate by the scale factor of 0.5 or half. We're going to take half of each of the coordinate points. So half of 2 and half of 6, both being negative, should result in -2, -3. X, -4, 8. When we take half of each of those, X prime should be -2, 4. Y is 4, 8. So Y prime should be +2, +4. Z, 4, -6. +4, -6 should result in 2, -3. So when we plot the coordinates, our original figure. And so what I want to point out here, if you look at it in the coordinate plane, we have 1 square, 2 squares, 3 squares, 4 squares. So this side at the vertices, X and Y, is 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So we should notice the reduction should be about 3.5, 2. Sorry. 2, 4, 6, 8, 10, 12, 14. Here, 2, 4, 6, 8. 8, 14. So when we complete this one, 2, 4, 2, 4, 6, and half of 2 is 7. Half. I'm going to highlight this side is related to this side. X, Y, and X prime, Y prime. From 8 to 4, we have a reduction of half. We have a reduction of half. We have a reduction of half along this side. 14 relates to this side, reduces from 14 to 7. So if we wanted to go from the figure to determine scale factor, we would relate sides that correspond to one another. In our last example, it says the vertices of a trapezoid are A, 2, -1, B, -1, 1, C, 0, 1, and D, 0, -1. Dilate the trapezoid using a scale factor of 2. Then translate it 6 units right and 2 units up. What are the coordinates of the image? So we know that first we're going to scale factor of 2 is we will take all of our X and Y coordinates, multiply them by 2. Then we're going to apply the rule 6 units right and left affect the X axis. If we're going right, we're going in a positive direction. 2 units up is also positive. Those are our rules. So 2, -1. So it says multiply by 2. A prime. And I'm going to erase this. A prime, -2 times 2 is -4. -2. -4, -2. D prime is 0, -1. So I should be at 0, -2. D prime. C prime is 0, 1. So I should be at 0, +2. B is at 1, 1. When I multiply, -1, 1. When I multiply it, I should be at -2, 2. B prime. BC went from 1 unit to 2 units. CD went from 2 to 4. And AD, this side, went from 2 squares to 4. 1, 2, 3, 4. Let's see what happened. And that worked. We know that because the scale factor is greater than 1, that A prime, B prime, C prime, and D prime should have been larger than A, B, C, and D. Now it says 6 units right. 1, 2, 3, 4, 5, 6 units right. 2 units up. 1, 2. Right. 1, 2, 3, 4, 5, 6. Up 2. 1, 2. 1, 2, 3, 4, 5, 6. Up 2. 1, 2. 1, 2, 3, 4, 5, 6. Up 2. 1, 2. So though my drawing is not perfect, this should be B double prime, C double prime, D double prime, A double prime. Double prime because we have 2 transformations. Transformation 1, transformation 2. So did that work? Plus 6 plus 2 to X and Y. A, B, C, D. And their image is a lot cleaner than mine. But we see that it worked. Translation 6 right, 2 up. Things to remember: today's Get Started and homework 2.5B is due tomorrow. Today's tutoring will be from 2:30 to 3:30.